Hey guys, how are you today? I hope you had a good weekend. First, I want to show you what the administrators, Mr. Pei, Mr. Micucci, Ms. Fowles, got for the teachers for Teacher Appreciation Week. I have this really cool sweatshirt or t-shirt, and you can see we're doing at-home learning. A lot of love for you guys. Peace. How about that? All right, so anyway, today we're going to work a little bit on factoring polynomial by its greatest common monomial factor. We have two videos for you.
Or you could maybe write this as 5 times 2x. That also gets you back to 10x. Okay, so these here would be considered factors. And you can see, this is a real basic example. There's a number of different ways to, a number of different approaches to factoring something. And there are oftentimes multiple ways we can write our factors. But anyways, so this right here is 4x cubed minus 2x squared plus 6x. So what I'm looking to do is to factor it in such a way where I have something times something else, and that's going to get me back to 4x cubed minus 2x squared plus 6x. Okay, so that's the objective. And what we're going to focus on in this particular example is the greatest common factor. Okay? So if you're not, this is the first time you're seeing this, I just say go ahead and watch the video once and get kind of used to what I'm doing here. So watch it through. I think after the second or third time, this will all start to click. But remember, what we're trying to do is to factor this polynomial. Okay, so greatest common factor. So this is how you do it. What you want to do is look at each one of these terms in this polynomial. Okay. Look at each one of these terms, and we're going to kind of factor each individual term. So 4x cubed I can write as 2 times 2, and then x cubed I can write as x times x times x. Okay? So this one over here, this negative 2x squared, I can write this, let's just kind of keep it as 2 for now, 2x times x, right? That's the same thing as 2x squared. And then 6x, I can write that as 2 times 3 times x. Okay? All right, so greatest common factor. The greatest common factor is the greatest thing that all three of these terms, the factors of these terms, have in common. Okay? So let's ask ourselves, what do all three of these factorings, all three of these terms, factors, have in common? Well, they definitely have a 2. Okay? Each one of them have a 2. So because they all have a 2 in common, that's going to be part of our greatest common factor. So that would be a 2. Now we just have to focus in on the x, okay, the x's. So this one has 3, this one has 2, and this one has 1. But guess what? Okay, the only thing that they all have in common is only one x, because this poor fellow over here only has one x. Okay, it doesn't have 2, it doesn't have 3. So all of them, at least, all three of these terms have at least an x in common. So they all have a 2 in common, and they all have an x in common. And beyond that, they don't have anything else in common. Okay, so 2x is the greatest common factor. All right? Okay, so hopefully that kind of made sense to you. And now what we have to do is to go ahead and use the greatest common factor to factor this polynomial. So what do we do? Okay? Well, we're going to write our greatest common factor like this, 2x, and then I want you to write 2 parentheses just like this. Okay? And I want you to be thinking to yourself about the distributive property. Okay, if I was going to take 2x and multiply it by something, okay, and I wanted to get back to my original first term, which was 4x cubed, what would I have to multiply 2x by? Okay, well, if you think about it, 2x times something. Okay, wait, let me just state this in a different way. 2x times something else gets us back to 4x cubed. What would that be? Well, we need a 2 to get that 4, right? And we need an x squared, because 2x times 2x squared will get me back to 4x cubed. So this is the whole idea behind factoring. Now, if you look at it, if I take my 2 and my x out, okay, that's my GCF, well, look what I'm left with. Okay, I'm left with 2x squared, right? So that's what I have here, 2x squared, as my factoring. Okay, so minus, okay, we're moving on to the second term now, 2x times what will get me back to my negative 2x squared? Well, I have my minus there, okay? It looks like I only need an x, right? Because here I have my 2 and my x is part of my GCF. So all I need is an x, and I'll throw my negative sign there, so it's a negative 2x squared. So if you think about it, 2x times this minus x will get me back to 2x squared, okay? All right, so like I said, if you're a little lost, just stick with this. Believe me, I've seen students when they initially learn this, they, it's a little tough for most students in the beginning, but after a while, a light bulb will click on. No big deal. All right, so 2x times what else will get us back to 6x? Okay, so just let's go back over here, look at our factors. 2x is our GCF, so 3 is what we need, right? So 2x times 3 will get us back to 6x. So this is the factor here, okay? We just factored this out. 2x times 2x squared minus x plus 3, because if you went ahead and used a distributive property and you took 2x times all three of these things, you would get back to our original polynomial, okay? And 2x is considered the greatest common factor.
All right. Factor in binomials. So binomial is basically a polynomial with two terms. So let's say if we have the expression x squared plus 4x. What can we do to factor this particular expression? The first thing you should look for always is to remove the GCF, the greatest common factor. The greatest common factor between x squared and 4x is x, because we can divide both terms by x. So if we take out an x squared divided by x is simply x, and 4x divided by x is 4. So the answer is simply x times x plus 4. So that's how we can factor the first expression, minus 18y to the 5th. So what is the GCF between 12 and 18? 2 can go into 12 and 18, so can 3, but also 6, and 6 is the greatest of those three. So the GCF will contain a 6. Between y to the 3rd and y to the 5th, the GCF is the one with the smaller exponent, so it's going to be y to the 3rd. Now 12 y to the 3rd divided by 6y cubed is simply 2. The y variables cancel. 3 minus 3 is 0, y to the 0 is 1. Negative 18 y to the 5th divided by 6y cubed. Negative 18 divided by 6 is negative 3, and 5 minus 3 is 2, so this is negative 3y squared. So this is the answer to the second problem.
Okay, we start with number 1. Here we go, first one. Okay, I'm going to work on 3 problems with you. The first one's factoring this binomial, 6x plus 9. So in each of these terms, the 6 and the 9, there is no x over here, so we know that we're not going to bring an x down. The GCF is going to be the highest number that goes into both of these, and that is 3. So down below I made a little note for myself. I took the 6x and I divided it by the 3, that's right there. And I took the 9 and divided that by the 3, that's right there. So as you can see, the 6x divided by the 3 would be 2x, and the 9 divided by the 3 would be 3. So the answer to my factorization would be the GCF of 3 times the quantity 2x plus 3. And if I were to use distribution, 3 times 2x, 3 times 3, it would bring me back to my original binomial that was 6x plus 9. Next up, number 2. Here we go, number 2. All right, so this example is going to be a little different because as you can see, we have an x in both of these terms. So first off, what's the highest number, the coefficient for 3 and 15? What is the highest number that would go into both 3 and 15? Good, so first up I factor out a 3. Now let's look at the x's there's an x squared, and there's an x. So I'm actually going to take this down and put an x there. My fault. So I factored out a 3x. My GCF is 3x. Now, if I were to divide 3x squared by 3x, I would end up with x, because x squared divided by x leaves me with just x. If I were to divide negative 15x by 3x, the negative sign would carry down. 3x into 15x goes 5 times. So the factorization of that problem is 3x times the quantity x minus 5. And last but not least, for Mr. Ogden's video, number 3. All right, so for the third one, a little more difficult. First off, it's a trinomial. There's 3 terms. And you can see that there is an x in all 3 of the terms. Further, each of the coefficients, okay, is divisible by 5. 5 goes into 15, 5 goes into 20, 5 goes into 25. So first we're going to factor out a 5. Now you can also see that there's an x to the third, x squared, and an x in that third term. So we know that we could take a 5 out, we said that already, and also there's going to be an x, and the GCF is going to be the lowest, okay, of those 3 x's, and in this case it's just an x. So our factorization tells us the GCF is 5x. Okay, so now we're going to sort of divide, where we take 15x to the third and divide it by 5x. 15 divided by 5 is 3. X to the third, x to the third, x. That's subtraction like we've talked about, and that becomes x squared. Then you can see for the middle term, 20 divided by 5 is 4. X squared divided by x, 2 minus 1 is x, just x. And then minus 5, okay, 5 times minus 5 is going to be negative 25. And since I already factored out the x, there wouldn't be any x right here. Okay, so today's lesson was a pretty simple one, where we're just working on factoring the greatest common factor out of a binomial or a trinomial, any polynomial actually. Tomorrow we'll go into special types of factorization of trinomials, and this is going to lead into that. So I'm going to put 6 problems on Google Forms, and you work those out. Do your best. If you have an issue, you want to know, maybe you need a little help or whatever, please get in touch with me. I'd be glad to work it through work it through with you, set up a little Zoom call, something like that. Do a good job.